Hello, hello. I think we're live. So if you're used to coming to these things, maybe you're expecting Joe's beautiful face, but instead you're stuck with my ugly mug. But I think we'll have fun anyway. So I am Garrett Bird. I'm a research software engineer here at Fluid Numerics, and we're gonna have a nice, easy, sort of relaxing afternoon. Maybe I can channel my inner Bob Ross today. But I'm here to talk about a latest sort of tool in the toolkit that we're simply calling SVG-to-HOHQMesh. And there's sort of a lot of different tools that this sort of integrates into, and so I'll go over them one by one. Um, First off, sort of what is the scope of the problem, I guess. What are we talking about? Um, well, here at Fluid Numerics, of course, we love CFD. And if you are trying to do computational fluid dynamics, you need a mesh. And so what I have pulled up here is a wonderful tool called HOHQMesh, which was developed by a few people. David Kopriva, Andrew Winters, and many others have contributed. Um, and HOHQMesh is a high-order hex quad mesher that we are using. Um, Today we'll be using it just for 2D, but it does 2D and 3D sort of um, procedural mesh generation. Um, and it's quite nice. So I'm going to walk through a little bit of documentation here for uh, using HOHQMesh. Uh, so I'm just on the GitHub here, and then you can follow the documentation here. It is conveniently linked. Um, And so here's sort of a visual example of what HOHQMesh can do. We have a mesh. Again, sort of today we're staying in the 2D realm, but you can do other things in 3D. Um, so it takes in a dot control file, and you can pass in a few different parameters to it to sort of define, like in this example, the outer boundary is sort of defined by this triangle shape, and then there's like circles and ellipses, and even like we can see like refinement regions in here, and even sort of this crazy spline shape in the middle here. And the spline shape is what we will be making the most use of. Um, so like I said, you can use HOHQMesh to sort of do things in a very systematic way. Here's an example, say for like uh, defining a circle parametrically, which is one way to do things. But another way to do things is to actually use spline curves. And essentially, what a spline curve is you feed in a set of points, and then the mesher will interpolate between those points in sort of a smooth way. So if you've ever messed around, one of the main pieces of software we'll be messing with today is Inkscape. So if you've ever used Inkscape, and you've messed with the cubic spline nodes in that, it's essentially the same thing going on. Um, and so this is sort of the groundwork, right? There's this really lovely background tool for generating meshes, and we have been working on SVG-to-HOHQMesh, which is exactly what it says on the tin. Excuse me. So if you don't know what an SVG is, there's really two types of images that two main things that maybe artistically you can think of dealing with on a computer. So you have what are called raster images, um, and this is what you deal with if you're using, say, like Photoshop, or like Microsoft Paint, anything where you have just a big rectangle of pixels. Um, yeah, it's essentially a 3D array if you're dealing with a full color image for like RGB each channel 3 dimensions. Um, it's just a big array of numerical values. The other type of image is a vector image, And this is essentially what like Inkscape deals with. And so instead of zooming in, if you think about like zooming into a raster image, eventually, you know, if you upload a picture on your phone or something, eventually it'll get quite pixelated because it's just raw sort of data being saved. But on a vector image and an SVG, these things are sort of generated programmatically. And so as we'll see when we get into it, you can sort of zoom in on these things indefinitely, and it's there, you know, each one has their purpose. What's nice about SVGs is with Inkscape and other tools, but mainly Inkscape, you can draw and generate all kinds of shapes and things quite easily, as we'll see. So all of this to say, we have HOHQMesh in the background, which is a wonderful mesh generator, and we want to be able to convert simple images, so you can very quickly adjust on the fly and do maybe a quick and dirty calculation for generating a mesh and then feeding it into your favorite computational fluid dynamics code. And so the README on this is quite extensive right now. It's not necessarily officially versioned, but we did just launch it, so you can think of it as like an 0.1 or a 1.0, so very early. So there is sort of a lot of cleanup to do, and we need to get it out of the brain and into the repo. But with that said, if you're watching this maybe in the future or even right now, I definitely recommend thumbing through the README here. Yeah, and this is a bit what we'll be doing today. So the sort of icon for svg-to-HOHQMesh is this pumpkin, which we'll actually be running a simulation on later, as we'll see. But this is sort of a very quick, sort of compressed way of showing what we want to accomplish with this. So you create an image in Inkscape and then turn it into a mesh. And so I have a quick little directory open here in VS Code. And so I have downloaded the relevant repository. So I have HOHQMesh, and later we'll use HOPr. I've already built HOHQMesh, and I actually have the binary right here. So I'm just going to use that to run. But I just wanted to mention that it is extremely easy to download and sort of build. And then I have the svg-to-HOHQMesh repository, which I should go back and say. The repository that we're looking at is fluidnumerics/svg-to-HOHQMesh if you want to follow along. And so we have our repository here, and it really turns out to be just about, I think just shy of 300 lines. Okay, just shy of 400 lines of Python, which is really not that much in terms of the usefulness that we've gotten out of it. So I'm just going to dive into it and sort of explain things along the way. So I already have an SVG file open here in Inkscape. So you can see that here, and we can actually get a preview of it in VS Code. And of course, it's not going to show anything because it's a blank file right now. And so part of this whole process is going to be me going through and sort of ticking off all the little checks of like, okay, make sure you do this, make sure you do this, make sure you do this. And some of that is part of a little bit of cleanup that needs to be done, and then also understanding how SVGs work sort of under the hood. And I'll actually start off with one of these sort of nitpicky things. So as you can see, I have circles.svg. I have this nice square canvas. So when you open a new Inkscape file, I'm not going to do anything with this, but okay, we have a new Inkscape file. You get sort of like the letter or A4 paper shape, and you can transform that with document properties into whatever you want. So I did 100 by 100 millimeters. Actually, I'll start off with two nitpicky things. So one thing is that when you're dealing with SVG-to-HOHQMesh, we rely on a tool called SVG Path Tools, um, which is a wonderful tool. But part of how that operates is that it uses millimeters only. So if I dive into the SVG here, we have sort of this metadata at the top, and we have width and height, which is specified in millimeters. If we changed it to like pixels or inches, those units would change. But what does not change is the view box. So the view box sort of, as far as I understand, the view box of an SVG sort of always thinks in millimeters, at least when you're saving things in Inkscape. And so if you have particular, like if you're drawing something and you need particular units, then think of it right now. It is best to think about things in terms of millimeters. And then the other sort of nitpicky thing. So we have our new Inkscape file. All I've done is resize the canvas. And you'll notice that we have over here in layers and objects, I have layer 1, which was sort of like cooked in. It was sort of brought up when I made the new file. And sort of an artifact of this. So if we think about this G attribute, so an SVG, I should back up. An SVG is functionally just an XML file, if you're familiar with that, with a few other things and like special attributes baked in sort of the standardized way. And one of these standard things is this G attribute, which we can more, for our purposes, you can think of G as being a layer. And so this layer 1 was sort of baked in by default. And then we resized it, and so it has this this transform applied to it. And for objects, we'll see that we can sort of like bake in that transform, but we don't really want to deal with it. But for now, I've found that the best thing to do is to just start with a whole new layer. That layer 1 sort of do not treat it with respect. Just create a new one, and I'm going to start with creating a layer called outer boundary, and then I'm going to delete that layer 1. So I'll save the SVG, and then if we look at this again, we have a G attribute, so a layer essentially, and then we see that it's called outer boundary. And the reason that I called it outer boundary in this particular way, if we look at SVG to control, which is SVG-to-HOHQMesh, this is the main file in SVG-to-HOHQMesh, and we look down sort of into the meat, and I'll go back up as it becomes relevant. But we're essentially parsing over each layer, and we do certain things based on the layer's names. So this seeks, I mean, it's just an if statement. If the name of that layer equals outer boundary, then do certain things, and I'll even skip ahead a bit. And we do the same thing for inner boundaries, as we'll see. But I'm just going to start with outer boundaries for now. And I'm going to start in sort of the simplest possible scenario. So I'm just going to use Inkscape's built-in tool to draw a circle here. And so it actually does not matter if you have, if I select this and then go over to like fill and stroke, it doesn't matter if this is filled or not. And it doesn't matter if you have a particular stroke style or not, because those are just sort of different attributes in the SVG. So it doesn't really affect the actual underlying geometry. Diving back into the file already. So we have our preview on the side, wonderful. And if we look back at the SVG, then we can see, let me make sure I saved, yep, so that is saved. If we look back at the SVG, then we have, just making sure, yes, in the outer boundary. Actually, I'm just going to go ahead and call this circle. In the outer boundary, we should have an object Okay, maybe I gave it sort of a confusing name. Circle is a sort of a first class citizen in SVGs. So this is if you're familiar, if you ever messed around with like maybe you've built your own website or something and you've messed around with CSS, I'm pretty sure that a lot of the sort of language that goes into defining geometries and things in CSS translates directly to SVGs. But I will say, but I'm not totally sure because I'm not a front end developer. So that might not be totally correct. But I do think it translates from CSS. That said, a circle is sort of like an intrinsic to the SVG language. All of that to say. Um, and then, like I said, here's the style attribute, which sort of specifies that it has a white fill and a black outline at a certain line thickness and so on and so forth. We have some other information, so like center X, center Y, and the radius. This is all sort of related directly to this circle class. And then, of course, we named it circle. But this is a bit of a problem. So the way that svg-to-HOHQMesh works is that we parse in paths and then we express them in when we write the HOHQMesh.control file. We are writing we're relying heavily on spline data. So basically a list of points. And it is doable, but it is nicer to deal with when we just have paths. And what I mean by a path in the context of an SVG. So a circle is what we can think of as an object, right? It's intrinsic to sort of the SVG landscape. However, in Inkscape, I can select this and then go to path and just hit object to path. And so it may not seem like anything has changed. But if we sort of go by the universal rules and notice the asterisk at the top of the screen here, something has changed. And so I've saved it. And we notice now that instead of being the circle object, it is a path object. And it still has this Inkscape label, circle. But then it has this D attribute, which is sort of long and complicated. And there's some wonderful documentation by Mozilla, actually linked in the README of SVG-to-HOHQMesh, that lightly explains actually quite in depth explains what each one of these things do. But for example, capital M means move to this position. The capital A is basically an elliptic arc with a few parameters in it to sort of, dictate like where the center is or how it's curving and so on and so forth. And so we're basically saying move to this point and then draw an arc given these parameters. And then if a new letter isn't specified, it just sort of you pass it parameters based on what sort of the previous segment was. So we start here, and then we draw an arc according to these parameters, and then from the end of that arc, we draw a new arc, and then draw a new arc, and then draw a new arc. So this makes sense. So we have an initial point for our circle, and then we have 4 segments, which we can think of as elliptic arcs. So it's actually quite nice to imagine as a circle, as being, if you're drawing a circle, you start at a point, and then you draw a quarter of it, and then 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 you're back because it's a closed path. You're back where you begin, and then Z just means end drawing, basically, sort of like a punctuation mark. All of this is sort of, you don't really need to know all of this to use the script, but it does give you a little bit of insight as to what's going on. And actually, we can verify this as well. So in Inkscape, you have sort of on the left here, you have your selector tool, which is sort of like you treat everything as an object. And then you have the node tool, where you can sort of look at all the little bits that actually make up that object and draw it. So as you can see, I think I have 4 nodes selected sort of in each of the cardinal directions for this. And if I wanted to, I could even sort of like squash them in various ways, and even move like the control handles, the control nodes, and get sort of these crazy shapes, which is quite useful and quite fun to mess around with. But I'll just keep it as a circle for now, sort of to make sure everything works. So this is sort of our test case, and I'm just double making sure. Okay, I've called that outer boundary. Here's another little quirk with svg-to-HOHQMesh, which I am actively working to resolve. So if you'll notice, I sort of intentionally named this path circle. So say if I create a new path from something, it should just give it a generic name like path2 or something like that. Rect1 because I made a rectangle object. But if I convert it to a path, it's still called rect1, but it sort of has these generic names. And so I'll save this and then go back and delete it. You'll notice that on my circle, it has this attribute called Inkscape label, and then the name circle that I gave it. But rect1 is just called by ID. And so it is quite the way that SVG path tools sort of parses in things. It is quite convenient to use Inkscape label, but it is a little bit more difficult to rectify things if you're just relying on ID. And so this is part of why it's sort of like Inkscape only compatible, where you should like do all of your SVG drawing in Inkscape, because we rely on this Inkscape label attribute. And Inkscape injects a bunch of other useful things. It's sort of for its own knowledge, and yeah, but basically, it injects its own sort of spice on top of the traditional SVG format, which is quite nice. It leaves a lot of information. Even like if I leave it at this level of zoom, as you can see here, it has like zoom information baked into it, and like where the camera is. And so if I like save this and then opened it up, it would open up like exactly where I'm looking right now. So I'll delete this rectangle, and then I think at this point most people understand what vector graphics are. They're sort of procedurally drawn. But I'll give the classic example of sort of continually zooming in on an edge here. I can sort of keep zooming in and zooming in and zooming in. It doesn't really get any more pixelated because it's being procedurally drawn, which is cool. And that's why we love vector graphics in 5 seconds. Okay, all of this to say, we have we have drawn a circle after all of that. And so using SVG to HOHQMesh is quite easy. So I'm just going to run this script and then pass in the SVG as an argument. So that is just circle.svg. Oh, wonderful. Wonderful. I will fake it and say that this was planned. Which it kind of was, actually. So we have an error, sort of built-in error detection in SVG to HOHQMesh, which detects if your path is oriented the right way. So what that means is that in HOHQMesh, when you're dealing with spline data, or you're using sort of the intrinsic tools to draw a path, to define your mesh, all paths need to be clockwise, and so HOHQMesh knows which way all the elements are oriented. Sort of, if you have an outer boundary and an inner boundary, it's if all these things are drawn clockwise, everything is oriented the same way, and it makes sense. in Inkscape, or really when you're dealing with drawing paths in general, things can be oriented clockwise or counterclockwise, and sometimes you don't know. So one way of making sure that it's sort of in the correct orientation is by trying to convert it to a control file and letting it fail. But there's actually some some conveniently baked in tools in Inkscape that can let us check visually. So I'm going to go over to fill in stroke, then go to stroke style, so we can do all kinds of crazy things and make this dashed and dotted and whatnot. But I'm going to keep it solid. But then I'm going to go to markers and then select an arrow. And then we can see that this is oriented clockwise. But if you're paying attention, I just said that HOHQMesh reads in things clockwise. So why isn't this working? This is essentially because like so in Inkscape, I have sort of gone into the settings and set my origin, my units, and my origin to be in the bottom left. And even if you set this, no matter what in Inkscape, it will think of drawing paths with the origin being at the upper left. So it's purely a sort of a one of these human things where I want things to be oriented the right way when I put them through HOHQMesh and summon them in ParaView and whatnot. But when we parse in these paths, we sort of flip them so they are oriented in this sort of like as we see them on the screen. And because we flip them, the orientation changes. And so in Inkscape, even though HOHQMesh likes things being clockwise, and they will eventually be clockwise, but in Inkscape we need them to be counterclockwise. And it is quite easy to do this if we go to, so select it, and then we can go to path and then reverse. And then we can see that now it is oriented the other way. And I'll just save that. And then I will run this again. And we'll see if there's something else that I've forgotten. Okay, so that worked. So let's look at this .control file. Wonderful. So to have a full grasp of what each of these parameters mean, I definitely recommend that you just head on over to the HOHQMesh documentation. It really has great documentation that explains all this. Most of these are sort of self-explanatory file names. In svg-to-HOHQMesh, it just sort of grabs whatever the SVG is called and changes the extension. Right now, we're not going to really worry about what mesh file format means, but we keep it at ISM by default. A polynomial order is, I think, semi-self-explanatory. It sort of asks to which degree accuracy do we want to keep sort of the shape of these things. And we have just found we use 7 basically as a default here at Fluid Numerics when we do things in self later on. We test with sort of 7 is sort of the default for us. And then for the plotting file format, we just stick with SEM. Background grid size. Again, I'll defer to the HOHQMesh documentation for a full explanation, but if you can think about a background mesh that is slowly refined to the shape of the SVG that you parse in, this is sort of the default size that it starts with. So if we recall, sort of the extent of this square is 100 by 100. And so we're basically starting with a default of like 5 by 5 chunks. So if we think relative to overlaying that circle on the square background, we can think of overlaying it on like a 20 by 20 background, essentially, in terms of number of elements. HOHQMesh uses spring smoothing. to generate the mesh, to make sure that things are not too crazy, and things uh, sort of space themselves out based on spring mechanics. And we just we provide defaults for these as well. And I'll say that you can specify all of this sort of at right near the top of the SVG to control script. So everything that we just looked at can be found, I guess, on line 52 in this area. And that can directly influence that. And then we generate, as we can see, an outer boundary. And then, so earlier we were thinking in terms of segments. This is sort of the normal way for SVGs to think when drawing a path. And so we stick with a default of 6 knots per segment. So if we can think of like 1/4 arc of the circle as being one segment, as we discussed earlier, you take the endpoints and then 4 more points that are evenly spaced between those, and then use those as your knots for your spline interpolation. And that's exactly what we do. And we just vary. I actually think it's required by HOHQMesh to vary between 0 and 1 for spline data. So for outer boundary, we can just sort of stitch together these spline curves. And right now they're generically named just outer spline 1, outer spline 2. But hopefully it is somewhat clear that this gives us our mesh. And actually, I'm going to check one more thing that I've forgotten to mention. So if we look back at our SVG file, we have our... Okay, so this one does not need to be transformed. I will cross that bridge in just a minute then, since this seems to be working, and that'll make sense in just a minute. But we've generated our control file. Very simple, no inner boundaries, just one outer boundary. And then I'll pass this quickly through HOHQMesh. Oh gosh. Apparently it's not in my history. It's because I didn't capitalize it, of course. Here we go. Would have been easier if I just typed it out. But it's easy to pass these files to HOHQMesh by just left Garrett right, just passing it in. So we'll do that, and we'll see that it was quite happy with that. We didn't get an error or anything. Jacobian is not near 0, which is sort of my first check for if things are going crazy or not. And so this output a circle.txt file. And so I'm going to load this in ParaView. If I can remember where I put this. What is the path here? Videos, live streams, okay. So if I open this in ParaView, we should get a circle. Okay, we have a circle, so I'm just going to check surface with edges, and it looks quite dense. I mean, we did kind of use a relatively small default grid size, but a lot of these sort of like extra lines are because we have a higher order, specified a higher order polynomial. So if you just want to see the outline of the elements, we can select outline in ParaView. And yeah, we have all of that work, and we have a simple circle mesh here, which you can definitely do probably much more quickly in HOHQMesh just by writing out a quick .control file with the built-in elliptic arc or circular arc modules. Uh, but the advantage comes with rapidly being able to change this, right? And so now we're going to go move into the exciting world of inner boundaries. So I'm going to add a new layer that is called, as we expect, inner boundaries. And I'm going to draw a new circle inside that, and maybe I'll give it a slightly different color to sort of differentiate it. And this isn't even a circle, this is more of an ellipse. So I'll be careful and call this inner ellipse, something like that. And then I'll do my due diligence and make sure it is oriented the right way. So it's oriented the other way. So again, I'll select that and then reverse it. Excuse me, I need to make it a path and then reverse it. There we go. So now it's facing the right way and it's a path. And so we can see that it's roughly in the middle of the circle here. So I'm just going to run our script again. Okay, it seems to work. But I'm going to go in and turn on plot, which is just under the debugging section here. And this just plots it. It's a very quick and dirty plot in matplotlib. So I'm going to do this again. Okay, and we see that it is in the middle now. Wonderful. I was actually hoping that I would mess something up. Let me do this very quickly. I will draw a quick path, and I'll be sure to draw it counterclockwise. Yes, counterclockwise outside. So I've drawn this path outside of the circle, and I'll quickly rescale it. I'll even move this guy. So I will rescale this, move this in, and then call this try or triangle. The intended effect. So if I look at the circles.svg now, yeah, again the render is showing it correctly, so that's good. And then in their boundaries, we can see that we have try here and inner ellipse as we specified. I'm trying and failing to get the SVG to add a particular attribute. So apparently I cannot remember the exact conditions off the top of my head. But so if I scroll up here, I think this is just for like the markers. You can see that sometimes in these paths, Inkscape will, and really this is more generally an SVG in general thing. But we can get this transform attribute for a path. And this could be rotate, this could be translate, scaling, or a few other things. Or even, I think, it's called matrix, where it sort of like bakes all the transforms into one matrix that it just applies to that path. And sometimes you can get these if you are making a mesh and things don't quite look like where they should be, where they appear in Inkscape, and then you plot them with matplotlib. If they don't look as though they are where they should be, it could be that you have one of these transform operations going on. And I wish I could get it to sort of bake them in. But regardless, I'll treat this sort of as a warning. If you do encounter one of these sort of like weird geometry quirks, then you can just go to transform in Inkscape. I think they go to this is object transform is how you sort of unlock this tab over here. And you can, if you sort of click through these and apply all of them, I think matrix might apply all of them at once. But if you apply all these, it'll sort of get rid of that transform attribute. So just something to be mindful of. But this one seems to not have any of them for whatever reason, and I'm actually going to delete this guy just because I want to focus on this. Keep things simple. So we now have inner boundaries and outer boundary. So I will run this one more time. Okay, seems happy. And if I go back to my control file, now we'll see that instead of outer boundary, we now have inner boundary, which is sort of set up in the same way. And then each individual, say if I have like two separate inner boundaries, then these will be two different chains. And if you're familiar with HOHQMesh, then this will make sense. And if you're not familiar with HOHQMesh, I'll echo again and say go read the documentation. But it basically stitches together different segments and makes them distinct from one another, makes different inner boundaries distinct from one another. Okay, so this appears to be happy. So now let's generate a mesh with this. Okay. So I will reload the file now. And now we have this lovely ellipse in the middle of our circle. So that's cool. And I'll even throw out here, maybe if you're experimenting with things, I'll call this inner ellipse 2. Maybe you're not quite sure if you want something in here yet, or you're debugging. You can add a new layer. You can call it whatever you want, as long as it's not outer boundary and inner boundaries. I usually just call it like temp or scratch or something. And you can drag this to temp, or whatever you call your other layer, and SVG-to-HOHQMesh should be happy with this. So I do have two sort of like inner boundaries here, but one of them is not in the inner boundaries layer. Yeah, so as you can see, it rewrote the control file. Then we can run that and then reload it in ParaView. Yeah, I did shift that one, but because that other sort of like scratch inner boundary is not in the correct layer, it just passes over, which is quite nice for if you're maybe developing something, or as I said, it's quite useful for debugging. So now I've spent a lot of time sort of rambling talking about how Inkscape works. So now I'll do something a little bit more fun than just drawing a circle with these default tools. I'll go through the what we talked about earlier. I usually just set things to 100 and 100. It really doesn't matter. And yeah, I'll just call this drawing. Outer boundary. So now I'm actually going to swap over to the Cintiq. Oh, hopefully you can still hear me. I believe you can. So I'm going to, yeah, just called pencil. I'm just gonna draw a boundary for us. Something nice and organic. Maybe not quite as good as a happy little tree, but I think that looks pretty cool. And then I'll just name it something. And then this is where the this is when we get into the realm of knowing how to clean things up, and that being quite useful. So if I select this, and then go to nodes, we can see that even though this is not a super complicated shape, because my hand, I've had some caffeine and my hands are shaky today. We have lots of little sort of nodes piled up and clumped up, which we don't necessarily want. It adds computation, and sometimes it can really throw things off. So I'm actually just going to select this object. So select object, and I'm going to path, and then simplify. And as we can see, we have way fewer nodes here. And then another thing that tends to make things behave a little bit better is hitting this auto smooth, make selected nodes auto smooth. And so that just sort of does exactly what it says. It just sort of automatically smooths things out a bit. So that looks that looks good to me. This sort of abstract shape. So if I swap back over to my screen here, I will specify instead of circle.svg, I will do drawing.svg. It's reversed. This is why you dot your I's and cross your T's. So I will select this. It should already be a path, but why not? That won't hurt anything if you hit object to path again. So I will reverse this. And I'll even go as far as to show us the arrows. Yep, that's what we want. All right. So if I go back over to VS Code here and I run this again, we do get a warning. My best explanation for this warning is that well, in this example, 0.68292 is not that different than 0.68291 repeating. But Python does not know that, and so we basically say if at the end of a path, if you draw a path, you know, given all your segments, and you start here and you start here, and your starting point and your ending point are just a hair off, you know, due to a floating point error or something, then they're basically on top of each other, and ignore that. Because if they're right next to each other, SVG path tools, the Python package will sort of try and create a line between those, and things can get messy. Anyway, and we're just accounting for that. So this seems to have worked. So then I will run it through HOHQMesh and see if anything breaks. So this was just a drawing.control. Okay, seems happy. So I will load that up quickly. I'll hide that guy, and then we'll look at this. Oh yeah. Oh, look at that. Isn't that cool? So now I can go back in to Inkscape, and I can start drawing inner boundaries. Inner boundaries. There we go. Maybe I'll create a crazy, scary face. So I'll actually be careful and draw these counterclockwise. So that's what they will be at the end. Okay, so there's one eye. I think most people have two eyes. There's another one. And then I'll have to reverse this one because I'm actually drawing it clockwise. And then there's that. And so I guess just to demonstrate the point there, I literally drew it clockwise. So yeah, we can see that it is oriented clockwise. But I'm going to select all of these and then do the usual. Simplify. Makes things way easier. We have a little bit of sort of crookedness right here that I'm going to investigate. Yeah, maybe auto smoothing will buff that out. So I'll select these guys again. And boop, boop, boop. And then let's do go to the nodes, select all of those, and then do auto smoothing. There we go. Maybe these are not closed right here. This looks a bit odd. Yeah, so this is something to be careful of. We have two nodes sort of right next to each other here. we're getting a little bit of funkiness, which is okay if we account for it. So I'm just going to delete this guy. And then I'll select these and auto smooth them. There we go. There we go. We're looking good. And then I'll come back over and just name each of these. That would be a mouth, I believe. That is I1. And that is I2. So we have our freaky little face here. So then if I go back into VS Code, I'll do this one more time. I even talked about it and I still forgot. Here we go. I'm not going to swap screens. I'm just going to quickly reverse that guy. Okay, so the mouse is reversed now, so this should be good. Okay, seems to be happy. So then let's run that through HOHQMesh. Wonderful. I bet we have some small elements sort of around the curvature of probably the eyes, but let's see. So here is our sort of weird potato head. And then if we reload this, we can see our friend here has appeared. I think this is cool. I get excited about this, that you can just go from doodling stupid little doodles into CFD meshes so quickly. And you can do, I mean, mesh. I mean, people make whole careers out of mesh refinement, so you can always go back in and tweak things. Like, this one turned out fairly well, but like maybe around like the edge of the eye here, maybe I might consider this curvature to be too sharp, and so I might flatten that out or something, or maybe right here. All little usual things you can do with mesh generation. Oh man, I've been rambling for a while. So this is sort of like the goal, the meat and potatoes of the freedom to draw a domain and then parse that into a fluid solver. And so I would like to mention HOPr here. So HOHQMesh is fantastic for generating meshes. Of course, here at Fluid Numerics, we have the spectral element library in Fortran, which is our personal favorite fluid solver for conservation laws. But to parse in HOHQMesh meshes into self, we use a tool called HOPr, which is I like to think of it as a sort of universal translator for meshes. Don't hold me to the universal part, but it is how I like to think about it. And so if I go back to the svg-to-HOHQMesh, we have our sort of mascot pumpkin here. Or I guess it's a jack-o'-lantern. We spent a lot of time sort of refining this and doing the usual things. There are some small tweaks that you can do. I guess I will demonstrate one thing quite quickly. So if I go back to this dude and I draw, actually I'll generate a triangle. We'll give him a little bit of a nose, I guess. We have our triangle. Oh. And I'll lower his mouth just to give it some room. We have our triangle. Objective path. I think these are not oriented correctly by default. So I will name this as the nose. I will check its orientation really quick. Okay, yeah, so that needs to be reversed. The path, reverse. Cool. And then I will come back over into VS Code and do the usual things. Things might be getting quite cramped, so we'll see if HOHQMesh is happy with this. Okay, yeah, HOHQMesh seemed to be happy. So I will reload this with his new nose. It's a bit off center, but that's fine. So one thing to keep in mind, right? HOHQMesh can handle these sort of sharp edges of like triangles or other polygons fairly well. I mean, you do get the usual artifacts of like wide angles sort of around the edges, but that is, in my experience, this is sort of par for the course for mesh generators. But it handles these quite well. Um, but if I go back onto, actually, I'll just drag it here. If I go back into this guy, then I take his nose and then I round it a little bit. So, oh, that's a lot of bit. Here we go. So I'll just take the top of his nose and round that. If we can sort of see that, I'll get rid of these arrows. There we go. So we have this sort of seemingly nice round shape at the top. But if I go back into VS Code and do, you know, re-chant the usual incantations. Okay, we actually got a negative Jacobian, which sort of illustrates my point here. I could spend more time tweaking this, but my point here is that one thing to keep in mind is that rounded edges maybe do not behave quite as well as nice sharp edges. And so to bring it back around with our jack-o'-lantern here, we actually ended up going from these like sort of soft rounded eyes to these sharp eyes because it handles it better. And to sort of complete the idea, we parsed it through HOPr and into SELF using the linear Euler equations, using no normal flow boundary conditions on the outer boundary and then on the eyes, nose, and mouth. And so we ran that in SELF, and we were able to visualize it using PySelf, which is sort of our active development visualization tool in Python. So I think I have that. Not here, I have it in this one. So you should be able to see this, I think. And so for initial conditions, we just did one of these classic sort of Gaussian bumps. I think it looks cool. I think this is awesome. That there's a neat the novelty of being able to draw something and then just it very quickly impose boundary conditions. And I can even show you the F90 file here very, very quickly. It's really not long at all. Accounting for comments, it's way less than 100 lines of code. And really the only two main things, accounting for like CFL conditions and other things, the only things you would really have to change would be the line to read in the mesh, and then I mean this line sets no normal flow, so you wouldn't really even have to change that. Maybe some initial conditions with where you want the bump. Maybe you don't want to give it a third eye, but it is a neat workflow, I think. So like I said in the beginning, this is definitely still quite in the early stages. I know I spent a time sort of talking about this was sort of like a weird Inkscape tutorial in kind of a weird way, but it's a really cool tool that provides a lot of functionality for this kind of thing. So it's definitely still in the early stages. So I encourage everyone to go out and break it. I know I have been breaking it quite a lot, and trying to remedy that as quickly as possible. With that, I think I think I can see questions, but if not, I'm sure I will be let known. But please, if you have any questions or any comments or anything, let me know. In the meantime, I will pitch the usual stuff. You can find fluid numerics on Open Collective. Particularly, you can go and support Self, the spectral element library in Fortran. You get access to a bunch of cool stuff. A Slack channel with the fluid numerics developers. And and input is a good way to put it. You have some pull in terms of what we will work on for Self. Currently, we're in a nice stage of sort of the interface is really at a lovely stage, and we're just sort of pumping out models. We have axisymmetric on the horizon. Uh, nonlinear Euler is sort of the new thing right now. A lot of stuff on the horizon. So I don't think I can see the chat, but I will pull it up to the side. Okay, here we go. Oh, I see Joe's answering stuff. Okay, my bad. Um, um, that's all that I really have to say. I'm trying to go through the checklist. Please check out HOHQMesh and support that project. That's really the backbone. Um, Definitely check out svg-to-HOHQMesh if you enjoy drawing. I would love to do more. Now that the basics are out of the way, maybe we can have some Bob Ross style drawing and CFD simulations on the horizon. We'll see. But thank you everybody for joining me today. And if you're in the States, then have a lovely Thanksgiving this Thursday. And if you're not in the States, have a lovely ordinary week. And we hope to hear from everybody soon. Please stay. I don't know if the chat should stay up for a little bit, so we should be good there. All right. Thank you all so much. See ya.